morning, dear friends. Namaskar, Mitro. Once again, this is Bhatt with you. In the last video lecture, we discussed about the lens maker's formula, how the lenses are designed. That we discussed in the last video lecture. Hope you all are doing well in this lockdown period. I have been uploading my video lectures regularly, and I am very much happy to know you all are watching these videos and learning in your own way. I really appreciate your interest in this mode of learning. If you have not subscribed this channel, please subscribe, like and share so that everyone can take benefit of it. Don't forget to press bell icon button so that you get the notification of every new video lecture. Thanks for being with us. Keep watching, keep learning.
So let us begin today with the new topic that is related to optical instruments, and the very first optical instrument we are discussing today here is simple microscope. I have shared some text here. You can see a simple microscope is a convex lens in which object is placed between focus and optical center. And as we know, if object is placed between focus and optical center of convex lens, it forms a virtual, erect and magnified image. So this is used particularly for magnifying the size of image, and therefore it is known as magnifying glass also. As far as simple microscope is concerned, this is the very fundamental device or instrument in the field of optical instruments. So there are two cases of image formation which are considered here. The first is when image is formed at D. You might have studied in class 10th that there are two vision points of normal human eye. The first is near point and the second is far point. So we are referring these 2 points for the image formation. The first is image is formed at D, and the second we will consider image is formed at infinity. So let us begin with this first case, image is formed at D. So how to understand the image formation in this case, that will continue in this lecture. So let this is the convex lens we are using as simple microscope. So this is the symmetrical vertical line, this is the principal axis of this lens, this is optical center, let this is focus. The same distance we would take in the right side as well. So when object is placed between F and O, let this object is AB. So we'll take two rays into consideration. The first ray is parallel to principal axis. What will happen to this ray? It will pass through the focus after being refracted. The second ray we are taking through the optical center. So these two rays are not really intersecting. If we produce them backward, then definitely they will meet at some other point. There the image is formed. So this is the location of image. A dash, B dash is image in our case. So now the diagram we had drawn when we were talking about image formation by convex lens. So now the very important term here is angular magnification, that we did not cover in the uh, other section where we discussed about the image formation by concave lens. So if we use here, then the angles made by object and image, then we have two important angles. The first is angle subtended by image, and that angle here it is theta I. If we draw an arc in length equal to the size of object, let this point is C, and at this point C is joined to the optical center, then that angle made by this is theta O. So here theta I is angle A dash O B dash, and theta O is equal to angle A dash O C. So the angular magnification which we have to understand here is M is equal to theta I upon theta O. So what is this? Ratio of angle subtended by image formed at D to the angle subtended by object at D and seen directly. So now we have to find out about these two angles. So for the purpose we will use the corresponding triangles. In triangle A dash O C we can have tan theta O. Let this is equation number 1. So tan theta O is equal to A dash C upon A dash O. For a small angle, theta O is equal to A dash C upon A dash O, and A dash C is equal to AB. Therefore, theta O is equal to AB upon A dash O. Similarly, we can have for tan theta I also. Tan theta I is equal to A dash B dash upon A dash O. So theta I is equal to A dash B dash upon A dash O. If you replace for theta I and theta O in equation 1, then what we'll have for equation 1? It will give us m is equal to A dash B dash upon A dash O upon AB upon A dash O. If you simplify this, it would be A dash B dash upon A dash O into A dash O upon AB. So A dash O is cancelled. Then what do we have? Then we have m is equal to A dash B dash upon AB. And A dash B dash is what? Image. AB is object. So m is also the ratio of size of image to the size of object. Size of image upon size of object. And we know from the definition of magnification, size of image to the size of object also can be written as the image distance upon object distance. Now if you see the diagram, we will understand few more things very easily. Wherever the object is placed, that location is A. So this AO is what? U. A dash is the location of image, and that distance we have taken capital D. So V is D here, but we will use V and U symbol for the ratio of size of image to the size of object. Using length equation, 1 upon f is equal to 1 upon v minus 1 upon u. So 1 upon u is equal to 1 upon v minus 1 upon f. Then we can have m is equal to v bracket 1 upon v minus 1 upon f. If you open the bracket, you would have v upon v minus v upon f. That can be written as 1 minus v upon f, and here v is equal to minus d, and d is 25 centimeter. You know very well, this 25 centimeter is denoted by capital D. So m is equal to 1 plus d upon f. So what it is? It is the angular magnification of simple microscope for angular magnification for image at D. So it's very easy. We have seen, we have followed only few new things here, rest other or as it is, as we had seen in the case of image formation by convex lens when object is placed between focus and optical center. So in that way we could understand about the image formation by simple microscope when the image is formed at D. Thanks for watching this video. In the next video lecture I will tell you about the second case of image formation by simple microscope, and that case is what? When image is formed at infinity. That is also quite interesting and you will enjoy the learning. So keep watching, keep learning. Thanks for watching this video, and kindly like, share and subscribe my channel. You will get all the updates whenever I upload any video lecture. You will get notification. For the purpose you should press the bell icon also. Thanks again. Keep watching, keep learning. Thank you very much. We will meet in the next video lecture. Okay, bye.